physics friends, and welcome to 1.5. I'm your host, Mr. Hare, and you've made it through almost chapter 1. Today what we're going to be talking about is data. How do we gather data? How do we manipulate data to make conclusions? Because that's literally what science is. Someone has an idea, someone then comes up with an experiment to test that idea, and in testing your idea, you're taking numbers. You're measuring something. And how do we measure? How do we measure accurately? And then what do we do with that data afterwards to make conclusions? So that's kind of where we're going today. So first of all, what is a measurement? What a measurement is, as far as I am concerned, it's a comparison between a known standard and something else. So if I wanted to measure this pen, and I look at this pen, oh, it's 6 inches. An inch is a standard unit of measure. So I'm comparing this against that, and it's 6 times that. Any measurement that we have in this world is always a comparison between a known standard and something that you're trying to measure. Now, measurements can be precise or accurate. A precise answer doesn't mean it's good, and an accurate answer doesn't necessarily mean it's good either. But what precision is how well measurements agree with one another. And then accuracy is how close they are to an accepted value. So for instance, if you look at these targets down here, if you only have one answer, if you only take one measurement, you cannot be precise. No scientific study is ever done only doing an experiment once. We do it multiple times to see how well the experiment works, to see how well our machine works, to see how well we are at measuring. So letter A, it is accurate. It's very close to the center, but it is not precise because you can't agree with another one. Accurate but not precise. Letter B here, it is precise. All the measurements are very close to one another, but it's not very accurate. For instance, in a lab setting, maybe you didn't zero your scale. So every time you're measuring, you're doing a really good job measuring how much something weighs, but when there's nothing on it, it reads 10 pounds. So it could be off. This is a very systematic error that's usually pretty easily fixed. You're multiplying instead of dividing. You're doing something the same every time. Letter C is the best. It's both accurate and precise. That's good. Letter D is the worst. It's not anywhere near the correct answer, and they're all over the map. This is very sloppy experiment taking. You're not measuring accurately, not taking your time to make sure that you're seeing what the measurement actually is. You're being very sloppy. So this is the difference between precision and accuracy and measurement. Now, when we graph data, we're going to graph two different variables. On the y-axis, we're going to use the dependent variable. And the dependent variable is the thing we, as experimenters, are measuring. The thing we as experimenters are measuring. We are doing an experiment, and that's what we're looking for. We're like, I wonder how much this spring stretches every time we put 5 more grams on it. So the dependent variable depends. That's what you're measuring. The independent variable is the thing that we as the experimenter manipulate. the thing that we as experimenters manipulate. A lot of times in experiments, you can always tell the independent variable. It's the one that goes up by a systematic amount. It goes up by 5 every time. It goes up by 10. It goes up by 1. That's the thing we're constantly changing to see how the dependent variable reacts. Now, what I did is there are 3 major types of relationships that we're going to encounter this year in physics. The first relationship is a linear relationship, like a spring. Like as the mass goes up, the spring stretches the same amount. So you get a linear relationship. The shape of this is called a line. Big surprise. Now, the general formula for a line is y equals mx plus b. This is something that you had to have passed algebra to get to me, so I know that you're very familiar with this y equals mx plus b. M is the slope and b is the y-intercept. The next type of relationship that you're going to encounter is called a quadratic relationship. When you're going up increasing amounts, distance a ball falls versus time. So every second that goes by, it falls further and further each time. The shape of this graph is called a parabola. And it has a general formula of y equals ax squared plus bx plus c. You have training with that also in algebra. The last type of relationship you're going to encounter is an inverse relationship. An inverse relationship has a shape called a hyperbola. This will level off at some point and reach what's called an asymptote. It will never quite reach whatever that asymptote is. This has a general formula of y equals a divided by x. Or you might see this as y equals ax to the negative 1 power. So I'm going to show you each of these real quick, and I'm going to show you how to use your Chromebooks to graph things, get a line of best fit, and then make predictions. So here's where you're going to get started. You're going to do this tomorrow in class. So I'm going to take you exactly through what we're going to do today, and then you're going to do this tomorrow in class. So what you're going to do is look at that data that I just had up. You're going to run over to Google Spreadsheets, and you're going to, first thing you're going to do is you're going to title this spreadsheet Physics Graphing Practice. And then you're going to look at that sheet that I give you, and you're going to type it all out. So you have to do mass in kilograms, and then we've got spring length in centimeters. And you're going to type your numbers. So 0, 5, 10. Let me show you how the pros do this. They don't type. If you've got something that's going up by a set amount, 5, 10, 15, 20, 25, 30, Google Spreadsheet will recognize the pattern if you highlight both of these boxes and then click this little box, drag down box here. It will fill it all in for you. Isn't that neat? So that's my first tip. How do you have Google Forms fill in a lot of numbers that fit a pattern? You just highlight the 2 boxes, click the drag down box, and away you go. The next thing I'm going to fill in is all those numbers. 13.7, 14.1, 14.5, 14. Bear with me. Now, when you guys type in this 16, you're going to probably find that no matter what you type, it doesn't let you get that 16.0. So what you have to do in that case is you have to click that box, and you can add as many zeros as you want using this button right here, or you can subtract zeros using that button. So you may come across this quite a bit. You need this for significant figures. So you have to have everything. If you wanted these all to have the same number of significant figures, you can add zeros or subtract zeros so you can demonstrate precision. So that's how you add zeros with this little button right up here. Now, if you need to make your column a little bit larger, let's say when you type this it doesn't quite work. If you double click in between here, it will auto format to the right width for you. Centering your text, that's pretty standard. Highlight what you want to center, and you can click this guy right there. You can make it left justified, right justified, or you can make it in the center. So that's how you center text, how you make a column wider. How do you add lines? Like if you notice here, I've got a couple lines in here that make it look nice when I go to print it out. It's right here on this box, so I'll take the lines away. I want to make an underline, so I highlight those boxes, click this drop down, put a line underneath it. Let's put a line down the center. Click that drop down, a line on the right. So I got my lines there. Now, that's making a chart. So right now you've just entered in data. You've done data entry. Now you're going to start to manipulate that data by creating a graph. Now, to do that, you're going to go Insert. You're going to insert a chart. Well, first of all, I think I'm going to highlight my data. So I'm going to highlight this stuff, Insert Chart. Now it's going to automatically put in, this is a column chart. I don't want that. So I go over here. You guys should be doing scatter plots. When you take discrete data, I want you using a scatter plot. I don't want you filling a line in. So you go over here to this chart type underneath data, and you can select the type of chart that you want. Down here, scatter plot. The next thing we're going to do is, it's really nice. Google Sheets, it's filled in the title for you. It filled in the y-axis units. It filled in the x-axis units. Everything's pretty much done. The next thing I want you to do is you're going to add a trend line. We're going to actually use math to predict what is happening here. So what you want to do is you go to, I think it is series. So you go over here to customize and you go down here to series. And I don't know what version of Google you're using when you see this. You could be looking at this in the future and they've totally changed around Google, but things are generally in the same sort of place. So you're going to add a trend line, and you can see that this line is a straight line. It doesn't go exactly through all my points. And then what I'm going to do is I'm going to label use equation. So here's the equation of this graph. So a better thing to do, so now that I've got this up here, the pros, when they go to make their graph, they're going to write their equation not like y equals mx plus b. The x value is mass. So what they're going to do is they're going to say 0.077 m plus 13.725 equals spring length, SL. There's the equation to this line, and it's much more user-friendly. Y's and X's don't mean a whole lot to experimenters, but M means mass, SL, spring length. That's going to be much more user-friendly when you write it down. So that's how you add a trend line, and that's how to display the trend line on the graph. Now I'm going to do a couple other ones, and just for the sake of time, I've already entered these numbers in, and I've already given them the right number of zeros, except this one. So I'll give it another 0. So I'm going to make a graph this time. So I think I forgot to put my milliamps here. Always have to have units. Highlight my data, insert chart. We want to make sure that it's a scatter plot. Look at this one as a line. It defaulted to a line chart, so I don't want that. I want scatter plot. And you can tell right now this is an inverse relationship. So when I go over to customize, I'm going to put on a trend line. Now, the computer is only as smart as the user. It thinks this is linear. It just defaults to it. You have to tell it what type of relationship it is. Now, if you want to do an inverse, it's an exponential function. Let's see. Nope, that's not it. See how it's got the letter E in there? You don't want that. So don't pick exponential. That is not right. Let's try power series. That's good. That's it. And look how it fits the data. A common thing that I see time and time again with students is you get this graph and then you'll click polynomial, because look at Mr. Hare, it kind of fits the data, but if you think about it, this line is going to rise back up again, and your data is not going to do that. This is an inappropriate graph to pick. Pick a graph that models the data. Don't pick exponential because you don't know the natural log. You don't know the letter E. You have no idea what it means or how to use it, so don't pick something that you don't know what it means. So down here to power series, and if you look at it very closely, this is real close to what I had just talked to you about with relationships. This would be y equals 75.5x to the negative 1 power. That's almost negative 1. So this is just y equals 75.5 over x. Instead of using x and y, a better thing to use would be resistance, R, because that's what y is these things, equals 75.5 current, C. Or you could even write resistance and current to make it more applicable. So here's how to do an inverse function. You choose the power regression when you're doing that. And then this is just usually rounded up to negative 1. It's going to make the math way easier. Don't worry about it if it's not. And then lastly, I think I picked a quadratic for my final one. And I have. So when you go to add your trend line here, I think if you just double click on this, customize series, to do a quadratic, it's a polynomial. And it's a polynomial of order 2. This really harkens back to what you did in algebra class. If you remember, y equals 6x squared plus 2x plus 1. Y equals 3x to the third power plus 2x squared plus 5x minus 1. This is a polynomial of order 2. That's also known as a quadratic. This is a polynomial of order 3 because it's the largest exponent. So this is a I think it's a quintic. Don't quote me on this, but this is not what you want. You don't want an order 3 polynomial. We'll not be doing that this year in physics. So when you choose the line of best fit, choose polynomial, and it says degree order right here of degree 2, and then use the equation as the label, and you can print it on there. Now, if you ever want to know how closely your line fits the data, it says show r squared. The closer that number is, let's see, r squared, where did it go? Did it pop up? It equals 1. So the closer the r squared value is to 1, it fits the data perfectly. I'll take that away. So let me now graph. I'll write the equation to this in a much more user-friendly way. Remember, it's y equals 5.4x squared minus 1.3x plus 0.7. I rounded those numbers, but now I'm going to change the y and x. Here are the y values. The y values are distance. So I'm going to say d equals 5.4. The x values are time. They didn't print out in there. 5.4 t squared minus 1.3 t plus 0.7. So this is a much more user-friendly way to write this equation. Write it with letters that mean kind of what is in the graph. That's going to help you when I ask you questions about how much time is it going to take to get to be 40. So then you can put the number 40 in for the letter D and you solve it for t. So putting it in a way that you can understand is much better to deal with than x's and y's. So this is what you're going to do. Tomorrow in class, I'm going to give you a sheet that's got a bunch of charts on it, and then you're going to put it into your Google Sheets, and you're going to pump out some graphs, and I've got questions about those graphs. So good luck.